All right, let's get into this deep dive. I want you to think about the most basic electrical command there is.
Just flipping a switch.
Exactly, just a simple on-off. But what if you need that on signal to happen instantly, like 20 kilometers away?
And not just 20 kilometers, but across an electrically noisy city.
Right. How do you guarantee it works every single time? That's what we're looking at today.
It really is. We're focusing on the tech that makes that possible, specifically a unit like the F-4CC, which is designed to send these simple on-off commands or contact closures over fiber optic cable.
So it's basically a remote relay, a really, really long-distance on-off switch.
That's a perfect way to put it.
Okay, but it sounds almost, well, too simple for today's tech row. Why not just use some standard network protocol?
Well, it really all boils down to reliability. Absolute, bulletproof reliability.
I see.
This kind of system handles two main things. First, you have what's called a dry contact closure.
Which is just a simple electrical switch, literally an open or closed circuit.
That's it. And second, it also supports 5 VPP TTL signals.
TTL transistor logic, so a very low-level fundamental signal.
Exactly. So what happens is you short 2 pins on the transmitter, the TX side.
So you hit a button or maybe a sensor goes off.
Right. And on the receiver side, the RX, it immediately senses that change and closes its own circuit.
Ah, so it's a normally open setup.
Precisely. The default state is off, which is a critical safety feature. It only turns the remote device on when you actively tell it to.
And I saw in the source material, it's also pretty flexible. You can do a simple point-to-point, A to B, or even a daisy chain connection.
Yeah, for sequential control across multiple points. But that brings us to the big question, doesn't it? Why use fiber for something so simple?
That's what I was thinking. It's just sending a yes or a no.
It's all about noise immunity. A long copper wire is basically a giant antenna.
Right, it picks up everything. EMI, RFI.
All of it. Ground loops, you name it. When you absolutely cannot have a false trigger, fiber gives you total freedom from that from that chaos.
And the distances are just staggering. 20 kilometers on single-mode fiber is standard.
Or about 3,000 feet on multi-mode.
Yeah.
And it's a plug-and-play design, which is key.
Yeah, and built for extreme temperatures, too, from minus 20 C up to 75 C. That's pretty rugged.
It has to be.
So let's bring this back to the real world. I mean, where does this kind of robust, simple technology become absolutely critical?
The applications really show you where that foundational reliability matters most.
Okay.
Think about traffic signal control equipment.
Oh, yeah. A car pulls up to the line, tricks a sensor.
And that signal has to get to the controller instantly and without fail, even with high voltage lines buzzing right next to it.
I see. So there's just no room for error.
None. Same goes for, say, large-scale building automation and environmental controls or access control systems.
Alarm triggers, that kind of thing.
Exactly. Fire and alarm systems, PIR sensors.
Yeah.
They all rely on this because failure is just not an option.
So what you're really getting at is this is how you connect the oldest, most dependable form of electrical signal, a physical switch, to our modern, spread-out infrastructure.
That's it in a nutshell. The whole idea is to get total noise immunity for an instantaneous binary command over extreme distances.
It's taking the concept of flipping a light switch and giving it global reach with perfect reliability.
Yeah, that's a good way to put it.
So it leaves you with this thought. If these incredibly basic on-off signals are the backbone for huge systems like traffic grids and building security, what other complex systems out there rely at their very core on the robust long-distance transmission of what is fundamentally just a simple electrical impulse?